Hello, everybody. Today we're going to cover Chapter 6 on the integumentary system. And as usual, realize that you can always go back a little bit if you want, or you can slow things down. You can go back and rewatch whatever you want. I'd highly recommend you reading the chapter as always. And if you have any questions, please let me know by sending me a message. Or at some point talking with me. So I'm going to share the application screen with you from the PowerPoint. Okay, so let's first talk about layers of the skin. And of course, we're talking about this stuff that covers our bodies. The skin and the accessory structures like hairs, nails, glands, sensory receptors, these are all part of the integumentary system. The skin, and you've probably heard this before, is really the largest organ, at least by weight, of your body. And it's composed of lots of different types of tissues, a lot of the ones we've already talked about. We also call the skin the cutaneous membrane. There's two basic layers. There's the epithelial tissue that overlies the connective tissues. We have epidermis with the outer layer, and we have the dermis of the inner layer. Okay, everything below that is considered either hypodermis or subcutaneous tissue. It's not really considered the skin. Okay, so the epidermis, the outer layer, composed of stratified squamous epithelium, as we discussed in previous lectures. It's many layers of the flattened cells. And then you have a basement membrane that's between the epidermis and the dermis. The dermis is the inner layer. It's thicker than the epidermis. And this is the part that contains lots of different materials, connective tissue with collagen and elastic fibers, but also muscle, blood, nervous tissue. And then we have the subcutaneous layer, the hypodermis, which is beneath the dermis. It is an insulating layer, and it contains areolar and adipose connective tissue. Technically, it's not considered part of the skin. And it contains blood vessels that supply the skin. Now again, luckily, the skin is mostly the stratified squamous epithelium, which are the thin cells that can absorb the nutrients pretty easily. Okay, so this picture shows a cross section of skin. Here is your upper part, the darker purple pink. That's your stratified squamous epithelium. Okay, and all of this is the epidermis, all this at the top. Okay, this at the outer part we'll talk about here in just a few minutes is the keratinized layer, or basically dead skin layer. Now below that, all of this lighter pink, that is going to be your dermis, and we have a dense irregular connective tissue there. And then below that, the hypodermis or subcutaneous that has a lot of adipose tissue in it. Okay, here's a nice drawing of what the skin and the subcutaneous layers look like. And you'll be doing this in the laboratory also. You'll learn this diagram pretty well. Again, keep in mind that the epidermis is just this outer part. Okay, dermis is under that. And then we have the subcutaneous. The subcutaneous really kind of begins where you see the fat and where the blood vessels originate. Okay, and there's lots of different parts to it, and we're going to go through all these parts, but this is probably a good slide for you to start memorizing. Okay, let's talk about the epidermis first. Stratified squamous epithelium does not have blood vessels. Its deepest layer is the stratum basale, and it is nourished by the blood vessels from the dermis. And I'm going to show you all these different layers in a minute. One of the ways to remember the layers of the epidermis is come let's get sunburned. Come let's get sunburned. And so stratum corneum would be the most outer part with the dead layer of cells. Lucidum, subcumulate, and then get granulosum is the next, and we'll show this on another slide. And then spinosum and the basale. Okay, but again, the deepest layer is the stratum basale. And as the cells grow, they migrate towards the free surface away from the nutrient supply. And once they migrate and they get further away, the older cells, these are called the keratinocytes, they flatten out and they die. And keratinization is the process of the hardening and dehydration and the keratin accumulation of the epidermal cells. Now, this is a good thing. Okay, I know it doesn't sound like it'd be a good thing. It hardens and dries and just dead tissue, but keratin's a tough, fibrous, waterproof protein. And it helps us very much in protection in many ways, and we'll talk more about that. Now, as the cells reach at the outer surface, they become tightly packed, they develop desmosomes, and they form the outermost layer, which is that stratum corneum. Stratum corneum cells are eventually shed from the skin surface. The thickest stratum corneum is on the palms and the soles of the feet. And it's up to 1.4 millimeters thick. Most of the body has thinner epidermis, though, 0.07 through about 0.12 millimeters. And the functions, they protect against water loss, harmful chemicals, mechanical injury, and even pathogens. Okay, so these are the different layers. Again, let's get sunburned. Stratum corneum, stratum lucidum, stratum granulosum, stratum spinosum, stratum basale. Stratum corneum, again, is the outermost layer of mostly keratinized dead epithelial cells, okay, non-nucleated. Stratum lucidum. Now, this one you only find in the thickest skin. It's between the stratum corneum and granulosum on the soles and the palms. It's the only place you find it. The cells appear clear. Nuclei, organelles, and cell membranes are no longer visible in these cells. Okay, then the stratum granulosum, which is beneath the stratum corneum, usually in most of your skin. There's 3 to 5 layers of flattened granular cells. They have shrunken fibers of keratin and shriveled nuclei. Then we move down to the stratum spinosum, beneath the stratum granulosum. Has lots of layers of cells that have centrally located large oval nuclei and developing fibers of keratin. And here the cells are becoming flattened. And then finally, at the very bottom, before we get to the dermis, is the stratum basale, the basal cell layer. It's a single row of cuboidal or columnar cells that divide and grow. And this layer is the one that has the melanocytes in it to produce melanin, to give your skin color. Okay, now it's not always obvious at the divisions. Stratum corneum, yes, definitely. Stratum lucidum, if there is one, it's a very thin layer, as we said, but that one's only found in the palm and the soles. Stratum granulosum is next, stratum spinosum. So the stratum spinosum is the deepest layer. And then we move to the stratum basale at the bottom. Okay, now I want you to notice the dermis. It kind of goes up in these undulations, and we call this the dermal papilla. Those are the dermal papilla. By the way, and we'll come back to this. It says dermal papilla, it actually give you fingerprints while you can see those ridges. Okay, there are special cells in the epidermis. We have the dendritic Langerhans cells. They're found in the stratum spinosum. We have basically phagocytes, which are those dendritic cells. They protect the skin and the underlying tissues from infection. Then we have tactile or Merkel cells. They're found in the stratum basale, along with the sensory nerve endings for the tactile discs in the dermis, and they act as sensory receptors for very light touch. Okay, the melanocytes are found in the stratum basale. They produce the pigment melanin, and it absorbs ultraviolet light from the sunlight, and that provides a skin color. Melanin is distributed to the keratinocytes, and that protects from the UV radiation. So it protects us from DNA damage, fibroblast damage, and skin cancer. Okay, this shows some of those specialized cells: keratinocytes, dendritic cells, tactile disc, tactile cells, and then the melanocytes. Skin color. So skin color does result from the melanin pigment. Eumelanin is a brownish black pigment of the epidermis. Pheomelanin is a reddish yellow pigment found in certain areas, like the lips. Now, other things affect the skin color, like hereditary factors. So all people have the same number of melanocytes, believe it or not, but they vary in the amount of melanin that they produce. They have varying distribution and size of melanin granules. And then there are certain genetic changes in people, like albinism, which is an inherited mutation, where they don't have melanin at all. Okay, environmental factors do affect the skin. Sunlight, of course, as we were saying, but ultraviolet light from sun lamps and also X-rays. And then there are physiological factors. Oxygenation in the blood of dermal blood vessels will give a person more of a pinkish tone, but if it's a lack of oxygen, then it's cyanosis. It looks a little bit more light bluish. A vasodilation and vasoconstriction of your dermal blood vessels. When you get really hot, your blood vessels come closer to the skin surface. That's vasodilation. It's trying to give off heat. Otherwise, you will look lighter when there's vasoconstriction because the vessels are further away. So when you're cold, you'll see vasoconstriction. Also, accumulation of carotene pigments from your diet can affect your skin color, and then individuals that have jaundice. And this shows the pigment containing melanocytes. Okay. Again, it's right at the stratum basale. Okay, this cross-section shows some melanin granules in the keratinocytes of the stratum spinosum, and the melanin granules in the melanocytes and keratinocytes of the stratum basale. Okay, this person has albinism. Again, it's an inherited lack of melanin pigment in skin and hair. Some clinical application: indoor tanning in skin cancer. It used to be the thing to do. Everyone would go to get indoor tanning, especially in the cooler months. Exposure to sunlight or a tanning bed can cause melanocytes to produce more melanin, so that's what people like. The skin darkens. But tanning beds use doses of ultraviolet radiation, and these can overwhelm your natural protective responses and can lead to skin cancer. There's basal cell carcinoma and squamous cell carcinoma that comes from the epithelial cells in the skin. And then there's also melanomas that arise from the melanocytes. Melanomas tend to be the least common skin cancers, but they cause 80% of the skin cancer deaths, so it's the most serious. Okay, moving downward, the dermis, the inner major layer of the skin. It averages 1 to 2 millimeters thick. It contains projections that are called dermal papillae, which I mentioned earlier, and this is between the epidermal ridges of the epidermis. It binds the epidermis to the underlying tissues. The connective tissue layer really is the dermis. It has muscle fibers, it has nerve cell processes. We also have dermal blood vessels that supply nutrients to all the skin cells. The dermis contains the hair follicle, which is where the hair grows from, and sweat glands and sebaceous glands as well. Also, the dermis contains sensory receptors like the lamellated Pacinian corpuscles. These are the ones that detect pressure. And then the tactile myocin corpuscles for the lighter touch. The dermis layer, we say, contains two layers, the papillary layer and the reticular layer. The papillary layer is kind of the undulating layer. It's the most superficial next to the stratum basale of the epidermis. It is an areolar connective tissue. It's the thinner of the two layers. Again, this is the location of the dermal papilla, and that forms the fingerprints. The reticular layer is the deepest layer. It has dense, irregular connective tissue, and it's the thickest of the two layers. Okay, so this shows the dermis below the stratum basale of the epidermis. So all this is epidermis. Notice the dead keratinized cells at the top layer, and then the stratified squamous epithelium, and then we move into the dermis. And the papillary layer is this first layer that you see kind of undulates up and down, and then you hit the reticular layer. Accessory structures originate from the epidermis and they extend into the dermis or the hypodermis in many cases. The accessory structures of the skin include the hair follicles and your nails and the skin glands, both sweat and sebaceous glands. If the accessory structures do remain intact, injured burned dermis is able to regenerate, but not if it's too deep. Okay, the nails. This is the protective covering on the ends of the fingers and toes. And there's three parts of a nail. We'll show a picture in a minute. There's the nail plate, which is the body of it, the visible portion. It's really keratinized cells that overlie the nail bed. The nail bed is a surface of skin under the nail plate. The nail matrix is the active growth region. It's not visible, but it's at the proximal end of the nail bed. The lunula is the pale half-moon-shaped region that lies over the nail matrix. The nail matrix conceals the deeper blood vessels. And then you have the cuticle. That's the fold of basically the skin at the proximal end of the nail. It's part of the stratum corneum, and it extends slightly over your nail right at the lunula. Okay, so this shows all those parts again. Here's the cuticle, the lunula. This is all the nail plate. And the nail matrix is right in here. Okay, next, the hair follicles. So hair is going to be present on all your surfaces of skin except your palms and soles and the lips and nipples and parts of the external reproductive organs. The hair follicle is the tube-like depression of the epidermal cells from which the hair develops. It extends into the dermis or the subcutaneous layer. Now, when we look at actual parts of the hair root's what extends from the skin surface to the dermis or hypodermis, and it is inside of basically the follicle. Okay, don't confuse the root with the follicle. The root is actually part of the hair. The hair bulb is the deepest part of the hair root. It contains dividing cells of the hair matrix, because that's around the root. Again, don't confuse it with the follicle. And then you have the hair shaft, which is the portion of the hair that extends beyond the skin surface. This is dead epidermal cells. The hair papilla have blood vessels that nourish the hair. And hair color tends to be due to the type and amount of melanin, just like your skin. Okay, and your small hairs on your skin have erector pili muscles attached to them. They are attached to the hair follicle. They contract in response to the cold or fear, and they cause goosebumps. Okay, again, here's the cross section of the skin, and look at the details of the hair. So below the skin surface, we have the hair root. Above the skin surface, we have the hair shaft. And then as we go lower, this layer around the bulb is the hair follicle. That's actively growing cells. Then the bottom of the hair is the hair bulb. Okay. And the hair papilla, this is this indention into the bottom of the hair root and has blood vessels. And this is an electron micrograph of hair emerging from a hair follicle. Okay, hair loss. This is one of the things many people are concerned about, and a lot of people do lose more hair as they get older. The most common type of baldness is pattern baldness. The top of the head loses the hair, and this is called androgenic alopecia. It's associated with lowered levels of testosterone in men or lower levels of estrogen in women. Progenitor cells tend to be lacking in the bald spots, but stem cells are still present there. alopecia areata, where the body produces antibodies that attack the hair follicles. So this is an autoimmune hair loss. All right, let's talk about some of the glands. The sebaceous glands are a type of holocrine gland, which we've talked about before. They're usually associated with the hair follicles, and they produce sebum. This is a fatty material and cellular debris. It's important because it keeps the hair and skin soft and waterproof. Excess sebum can result in acne and tends to be absent on palms and soles. So no sebaceous glands, usually on palms and soles. And this shows you what a sebaceous gland looks like in a slide. Again, notice it is connected to the hair follicle. Okay, speaking of acne, or acne vulgaris, this is a disorder of sebaceous glands, common at puberty because those glands tend to produce excessive amounts of sebum, and it's responded to the androgens or hormones. The sebaceous glands become clogged with extra sebum and the epithelial cells, and this provides a good environment for the anaerobic bacteria, so infection will result and inflammation. About 80% of people between the ages of 11 and 30 years of age will get this. Treatment, we treat best with vitamin A derivatives, systemic antibiotics, salicylic acid, and benzoyl peroxide. Okay, the sweat glands, also called sudoriferous glands. They're very widespread in the skin. They originate in the deeper dermis or hypodermis as ball-shaped coils. And there are three types of sweat glands. There's the eccrine or merocrine glands. They're the most numerous. They consist mainly of water and some salts and waste as far as their products. They respond to elevated body temperature, and they open to the body surface through pores. So those are the ones we use mostly to cool off. Then we have the apocrine sweat glands. They're found in the axillary and groin areas, and they open into the hair follicles. They're called apocrine, but they secrete by exocytosis. They respond to emotions and pain. And then there's specialized sweat glands like the ceremonous glands, which produce airwax, and the mammary glands that produce milk. And yes, both of these are types of sweat glands. Okay, this shows the sebaceous glands attached to the hair follicle and root. And here we see the merocrine sweat glands. Notice it does have that coiled look. And then we have the apocrine sweat glands that are further down, closer at the bottom of the dermis and the hypodermis. Okay, but only the sebaceous gland here we see directly related to the lower part of the hair shaft. The apocrine sweat glands do release into the edges at the top of the hair shaft. Okay, this is another good table to get to know, 6.2. You may want to look at that again. It tells you about the different glands and where to find them and their functions. Okay, skin's very versatile, very important for homeostasis though. It helps us in protection, so it protects against harmful substances, UV radiation, microorganisms, and water loss. Skin is also necessary for sensation because we do have sensory receptors for touch, pressure, and temperature changes and pain. Also, we have excretion of some wastes at the skin with the sweat glands. We also have production of vitamin D in the skin. This starts in the skin. And when it's produced and activated, it helps with calcium absorption. So that's one of the main reasons you need vitamin D, for calcium absorption. And then there's regulation of body temperature. It helps cool your body by sweating and blood flow changes. It's important to regulate body temperature. You know, a slight shift can disrupt the rates of metabolic reactions. Your set point of temperature is monitored by the hypothalamus in the brain, something we'll talk about at the end of the semester with the nervous system. The deep body temperature is close to set point, about 37 degrees Celsius or 98.6 Fahrenheit. Skin does play a key role in homeostatic mechanisms that regulate the body temperature. And heat is a product of cellular metabolism. We mentioned that when we were talking about cellular respiration. It's mainly produced by most active cells, like the liver, the skeletal, and the cardiac muscles. Okay, different methods of heat loss through the skin. We have radiation. That's the primary method. It's really infrared heat rays that are traveling from the warmer skin to the cooler environment. Then you have conduction. This is when heat moves from warmer skin to cooler objects when in contact with it. Okay, so when you feel an object and it's colder, that automatically means your body's conducting heat to that object, and vice versa. If it feels hot to you, it's going the other way. Okay, convection, this is heat loss from the skin involved circulating air currents around you. And then you have evaporation, which is heat loss through sweat as it evaporates. This carries heat away from your skin also. Okay, body temperature regulation mechanisms. So when the body temperature rises, the thermoreceptors signal the hypothalamus of the brain, and you have vasodilation of the dermal blood vessels. Vasoconstriction of the deeper blood vessels also happens, and then the sweat glands are activated. Now, when body temperature falls, the thermoreceptors signal the hypothalamus, the vasoconstriction of dermal blood vessels happens, and vasodilation of the deeper blood vessels. The sweat glands then are inactive, and your muscles start contracting involuntarily, which causes shivering. You'll also see the erector pili muscles causing your hair to stand up on your skin to some degree. Okay, this is a body temperature regulation graphic, which just went over what we just did. It shows what happens if the temperature is too high, and then it shows what happens if the temperature is too low. And you'll see a lot of these models used throughout the textbook. Okay, because this is negative feedback, we're always trying to get back to a set point. Okay, there's problems that some people have in temperature regulation. And hyperthermia, this is when you have abnormally high body temperature. And it occurs on hot, humid days when sweat cannot evaporate. When air temperature is high, radiation is less effective. So the body may gain heat from the hotter air. Skin then becomes dry, and the person can get weak and dizzy and nauseous, have a headache, and have a rapid pulse. Hypothermia is abnormally low body temperature. It can result from prolonged exposure to cold or illness. Shivering is involuntary skeletal muscle contractions that's caused, again, by the hypothalamus. And this could progress to confusion, lethargy, the loss of reflexes and consciousness. And without treatment, the organs will start shutting down. Okay, in elevated body temperatures, you have a loss of ability of the homeostatic temperature control mechanisms to function in an extremely hot environment. So exposure to the very high heat can overwhelm the temperature control mechanisms, and that can lead to hyperthermia. If the body heat builds up faster than the heat can be lost, then the body temperature will rise, even if the set point's normal. Extreme vasodilation then can collapse the cardiovascular system, and that can be fatal. And then, of course, you have fever. This is when the set point's elevated by the immune system. It's trying to fight infections because the bacteria don't like the higher temperatures. So phagocytes, which are the white blood cells, release pyrogens in response to the presence of bacteria and viruses. The hypothalamus increases the set point and raises the body temperature. Elevated body temperature then helps destroy the pathogens. All right, now let's talk about how your body skin can heal. So inflammation is a normal response to injury or stress. It's the body's attempt to restrict the spread of infection. Any blood vessels in the affected tissues will dilate and will become more permeable, and this allows fluids to leak into the damaged tissues. Inflamed skin can become reddened or swollen or warmer or painful. Okay, as far as wounds, a shallow cut, this affects only the epidermis, will result in epidermal cells along the margin dividing rapidly, and that'll fill the gap. But a deeper cut, this is one that reaches the dermis or subcutaneous layer, will result in blood vessels breaking, and released blood forms a clot. The clot consists of fibrin, blood cells, and platelets. And the clot and dried tissues, fluid, form a scab. Epithelial cells will reproduce and fill in the wound. The fibroblasts then come in and secrete collagen fibers that bind the wound together. Growth factors then stimulate new tissue formation. The phagocytic cells will remove the dead cells and debris, and the scab will slough off. And then excess collagenous fibers could form elevated masses, and that's what forms scars. That forms because the epidermis isn't able to really renew the cells in those areas. So you're stuck with really the connective tissue. Okay, figure 6.16 shows the healing of the wound, all the things we just talked about. So you may want to look through this to see how those different steps do occur. Okay, burns. Burns are classified by the extent of tissue damage. Superficial partial thickness, that's a first-degree burn. It injures only the epidermis, like in sunburn. You'll see redness, heat, and inflammation. Healing will take days to weeks, but usually there's no scarring. A deep partial thickness or second-degree burn will destroy the epidermis and some of the dermis, like when a person is burned from hot liquids. It can blister. Healing varies with severity of burn and the stem cell survival. Stem cells in the hair follicles and glands can help regenerate the skin. Individuals, or the skin in these individuals, usually will recover completely with no scarring also. Okay, full thickness or third-degree burns. This destroys the epidermis, the dermis, and accessory structures. It results from prolonged exposure to heat and flames and hot liquids. Some healing may occur at the margins, but it often requires skin grafts or skin substitutes. The rule of nines is one way to know how dangerous the burns are. We divide the body surface into regions of 9% or multiples of 9, and it's used to estimate the extent of injured body surfaces from burn for treatment. From this estimate, then, the plans to replace the fluids and electrolytes in skin can be figured out. Okay, this shows somebody with a superficial partial thickness burn, a deep partial thickness, and a full thickness. Okay, the rule of nines shows you what we mean by dividing the body into 9% percentages. Like if the front of the leg is burned, that's 9%. The back of the leg is 9%. The entire arm itself is 9%, so the back's 4.5%, the front's 4.5%. The posterior trunk is 18%, so 9% for each half of the body. The posterior head and neck, 4.5%. The anterior head and neck, 4.5%. So you see why we call it the rule of nines. Okay, what happens with your skin as you age? Well, the cell cycle slows down, the skin becomes scaly, the age spots appear, the epidermis and dermis become thinner, a loss of fat and subcutaneous layers occurs, and people tend to feel colder when they're older because of that. Also, you start seeing wrinkling and sagging of skin because you start losing the elasticity or the elastic fibers. You also don't have as much moisture. Sebaceous glands secrete less oil. Skin becomes dry. Also, people tend to be paler. The melanin production slows down. The hair whitens. The hair thins. The number of hair follicles decreases. The nail growth becomes impaired. Sensory receptors decline. And body temperature regulation becomes a lot less effective. And finally, we have diminished ability to produce vitamin D. So these individuals may have a harder time processing calcium in the end as they get older. All right, that is the integumentary system. Again, feel free to go back through this again if you feel like you need to. And if you have any questions, as always, please let me know.